In 1814, Joseph von Fraunhofer was viewing sunlight using a device he developed when he saw some tiny dark lines in the sun's spectrum. Where did the other colors go? Well, let's find out together.
Light can be described in two ways, as a stream of tiny particles called photons or as electromagnetic waves. Weird, right? That's why we are going to use the wave model to explain light.
The worm we feel on our hands from a beam of sunlight demonstrates that light carries energy. But not all wavelengths carry the same amount of energy. It turns out that the amount of energy carried by electromagnetic radiation depends on its wavelength.
If we pass white light through a prism, it will spread out into the visible spectrum, aka rainbow colors. Now, each one of these colors has a different wavelength. For example, red light has a longer wavelength than blue light. You should also keep in mind that as the object's temperature rises, the amount of energy radiated increases. But how a spectrum is formed? Each kind of atom has different number of electrons. This means that each atom has a different set of electron orbits. Let us take the hydrogen atom as an example. If an electron drops from a upper to a lower orbit, the atom will release energy as light, make it colorful. But if we shine a beam of white light through a cloud of hydrogen gas, the atoms will absorb energy that will lift the electrons to upper orbits.
Absorption is a bit like pulling an arrow back. Emission is like the arrow being shot. In one case, energy of your muscles is transferred to and stored in the flexed bow. In the other, it's released as the arrow takes flight. If we take a closer look into the solar spectrum, we can notice that four of the missing lines are the emission lines of the hydrogen atom.
It means that hydrogen is there. And this is how we were able to determine the composition of the outside of the sun, and by using some cool physics, we figure out the rest. Stars are in fact the only objects for which we can identify chemical elements. Any spectrum from any object can allow us to look for the signatures of elements. This includes supernova, nebula, and of course, alien galaxies.